Here we go.
Hello, welcome to this video. In
This
this
is
video,
what
we're
we're
going to talk
doing
about.
today. I got Houdini in the Houdini engine inside of here, so we are going to utilize this to make vertex animations. Now I will show you why we are going to do that, and that will make a lot of sense. Yeah, we're not at a good point right now, and this is only 200 units, so we need to performance optimize this. Keep in mind, this is entirely I think this is entirely single threaded, no jobs, anything like that. But with that being said, it's like no special code, right? But like it's not really doing anything either. So like I could offboard this, but this doesn't run every frame. Right? So let's see if we get anything better with this. Because this here actually costs quite a bit, a surprising amount. So let's find out. And we're still low. Still low. But if we look at the CPU, yeah, the CPU is definitely where we're bottlenecked. Hey, Ashwin, how are things? Hmm. So the goal today is to get this back up to a reasonable amount with 200 units. How was the interview? Interviews went nowhere. Well, actually, I shouldn't say that. I'm still waiting to hear back, or if I'll hear back from the interview on Tuesday, and then the Thursday and Friday interviews. Um, the Thursday interview, the recruiter from the company was interested in me, but the hiring manager um, uh, doesn't understand my stack. Um, but also based off the conversation I had with him, it's not a position that I would be able to fulfill anyways, because he was looking for somebody with who is more into front end development, and I don't really do a lot of front end development, so it is what it is, right? He seemed very focused on React, and it's just like, yeah, I don't do a lot of React. He was like, "Where's your React experience?" And it's just like, I have some, but like I avoid that. I'm not a front end developer. So yeah, that one went nowhere. Although because yeah, yeah, like he only interviewed me because we have previous rapport, right? Like the Friday interview was only just because like we actually know each other. Because we've worked together. So yeah. He seemed to conflate, like he made some comments that didn't really make sense to me. Like he conflated like WordPress and Django as like equal, like the same style. Like if you can make like being a WordPress dev is a thing, right? And it does the skills that you make in WordPress do not transfer over to like regular PHP, right? But Django is not like WordPress in any way, right? Like Django doesn't provide you with much. Like yeah, it provides you with like a data, like an ORM, right? And but so Django provides you with like an ORM and just like the base level view. Like this is how we'll just like this is how you'll take HTML and get it to the front end, like send it to the front end kind of thing. That's all it takes care of. Or if you're using REST framework, it's like here's a serializer to take a string and turn it into a dictionary that you can use, or take a dictionary and turn it into a string that the front end can interpret as JSON, right? So I too started my Python, finished basic work on personal finance tracking for me with connecting to my account and expense from diff payments applications. Nice. Yeah. But like he was just like he was like a couple of times he like compared like like mentioned that Django was just kind of like pre-built websites and stuff like that, and it's just like that's not what Django is though. Like I don't know anybody that uses it that way. I think there's some libraries, like some library frameworks that people have put out that allow you to use it in a WordPressy way, but like I've never actually seen anybody use it in a WordPressy way. But yeah, he was just like, yeah, you've got no like application development experience, and it's just like when you say application, and then he was like referencing how like React would be like an application. And it's just like React is the front end to an application usually. Like you could make like you can make apps with React, but like they're not great. Actually, I shouldn't say that. They can be quite useful, but like it's just like that's not really something that like a lot of people do. Like it's when I say a lot of people, I mean like if you go out to like 90% of businesses, 90% of businesses are not using Electron. They're using web apps, right? Like they utilize web applications and they do everything in the browser because it's just easier, right? But yeah, like it was really weird. I was just like, I feel like you don't know what Django is. And it's just like Django is used to build Instagram. So like the idea of that you wouldn't build an application in it is weird. Yeah, like I don't know, like because he was like you need more Python experience. Like he was like you need more like actual Python experience. And it's just like what? I have 10 years of Python experience, like actual Python experience writing actual Python code, right? Like um yeah, like we use libraries, but like who doesn't use libraries, right? Yeah, it was really weird. It kind of like it really did feel like he was looking at Django through the lens of it is WordPress, but in Python, and that made a lot more of his comments make sense. But yeah, like he wasn't wrong in that I probably wasn't going to be suited for the position, right? Because like it sounded very React focused, and I do not enjoy programming in JavaScript, right? So, and I'm not a particularly skilled React developer. It's not like I can't do it. It's just I'm not good at it, and I am always on the struggle bus to get React anything off the ground. Like I was like for the front end for my language app, I was just like I'm going to build this front end myself and get this worked out. And then I sat down and I went to do it and I was just like, oh my God, I can't do this. It kills my motivation to do this. All motivation out the window the second I had to touch the front end part of it. And I was like, fuck. It's so bad.
How we can add the characters and use the vertex animation to actually have the animation of the character.
Yeah, and Ashwin, the weird part is that like he's been like a direct, like he's been working in that like kind of position, like building out a development team for like 10 years. So and he has a Python project in his portfolio, right? Like in that he manages, there's a Python project and it's just a Python web app, right? And it's just like I don't get it. Same to this on leak code. Yeah. I can leak code, man.
characters in the game engine. So in Houdini, I just have a empty scene. And for this tutorial, there are actually two things I need before starting. So of course, I need a character and I need an animation with it. So that's something I will not cover here, but I will give you some tips on what you could use. For example, you can, for example, use some of the templates.
The next time I do leak code, I'm doing it in C++. Mm. It's harder, but I think it would be more fun.
Templates we have, so we can, for example, type geometry, and in here, if you type in body, you will find a template void. So you will be able to use this. You can, for example, just export this as well if you wanted to export. So here, export FBX. Then we also have the labs test models. So we have Louise and Paul.
Okay, so let's get this started. So what we're gonna do is we're gonna do vertex animation textures. Is it this one? No, it's object. Here we go. And we want FBX character. Wait, what? What am I doing wrong here? Let's just do this. Okay, we're gonna do this. We're gonna do this. Discard and new. FBX import. Import? Wait. Character import? What the fuck is going on here? Okay, wait. I think I got somewhere that I'm not sure where. I was in the right spot. Weird. Oh, yeah. Friggin' leak code in Python is very valid. I've been doing Python for so long that I try not like my only issue with Python is that like it's really like one of the only languages I ever get hired to work with. And I'm a little bored of Python. So like that's why my personal app is in Elixir, not Python. Like I initially was going to do it in Django with Django REST framework, and I was just like, I kind of don't wanna. Right? Character. Do I not have labs? No, I do. What the fuck? Wait. Weird. Oh, there we go. Yeah. No. There is absolutely nothing wrong with using new project. Yeah, absolutely nothing wrong with using Python for this. For anything, to be honest. What are the good resources for Python as documentation? I use the Python API docs. I'm like actually not joking about that. I actually do use the Python documentation. Yeah. I am a big fan of that of the docs. So like if I come to here, right, and we do this, right? Like let's say random Python, right? There's this one. I don't like the W3 stuff for Python. I actually use this. Well, the thing is that you're not necessarily reading all of it, right? So like let's say that I need a random range, right? I would look for something like this, right? But like this is the random library. And then this is random range, right? And this tells you everything that you need to know about random range. Or if you want an integer, right? Because this I believe is going to return back a float, right? This will give you a random integer and such that a is less than or equal to n, and b is less than or equal to n, or sorry, greater than or equal to b. No, less than or equal to b, and a is yeah, yeah, whatever. So essentially, it's going to be a number. It's going to be a random integer between a and b, is what this says, right? Here's a random choice, right? Um, and stuff like that, right? So like you can go through here and you're not necessarily going to have to like you don't have to read all of this. You're mostly just reading this, right? You're reading this part here, right? And then if we come down here, we can see random, you know. So this is what we're fucking fucking stupid shit. Sorry. Like this is what we're looking for, right? And what we're doing is effectively we're just looking for the thing that we need, and then we'll read this if we need to. And sometimes they'll have like examples, right? And they'll have examples down here. Um I can guide you, but like the issue is that this just requires practice. So like if we go to here, let's go to the random int, right? Rand int. So if I want to utilize this, so let's open up Python and we'll use random int. I'll show you. I'll show you random int. So how would you use random int? Here's random, right? There's random, and we want to get a random integer between two numbers. Well, actually, let's start a new project. Uh, Python project, Python project. What? Python teaching. Okay. New file. Main.py. All right. So let's say that we want to use this to print out a random number of numbers or something like that. Or let's do 10 numbers. Let's make a quick app that does 10 random numbers, prints 10 random numbers between 1 and between 0 and 100, right? So how would we use this specific API call, right? Well, we look at random here and we can say that, oh, it's just random. Okay. So from random import randint or import random, right? So this tells us the pathing, right? This is how we import it. This tells us the pathing here. So we know that it's just random, right? So everything in here, if you import random, you get everything in here, right? So we know that much. Then if we go up to randint, now this says that it's going to return a random integer n such that a is less than or equal to n. So the return value from randint is going to be the n value, right? Here's a. So it's less than or it's a is less than or equal to whatever value we get out, right? So it's inclusive. And then we look at b, and b is going to be, and then n has to be less than or equal to b, right? So this is an inclusive upper limit of what we can have. And alias for rand range, right? And that's how we read it, right? Now, of course, you're probably aware if I import random, then every time I go to use it now, I have to do random.randint, and then I would give it a 0 and 100, and we can do this in a for loop or in range 100. There we go. And remember, because this is inclusive, this includes 0 and 100. But outside, like I know that was pretty simplistic, right? And I'm sure that you also found that pretty simplistic, right? But like effectively that's how you read these docs, right? So all this is automatically generated using a doc string, right? So if I have def print random numbers, right? Then all that is, all these are these functions, and then um uh the text to display, right? And then like down here we can have like there's a I can't remember what it is, but like because it changes depending on like what systems you're using. But like you can have like an example section, example, right? And then like, and I think examples are like dictated like this, if I remember correctly. To do example on how it's used. Um, ooh, I think personally, my favorite way to learn a language, and I find that this works the best for me. And the way that I usually suggest to people is build things. I don't personally, I don't think that leak code is particularly useful for that. Um, but it really depends on where you are in your journey, right? If you're already experienced enough and you've built things before, then leak code can be great for getting you up to speed on specific things or refreshing specific topics. Um, or filling in gaps that because you're self-taught, right? But if your goal is to actually learn how to use the language to build things, right? If you want to do web development in Python, pick a web framework for a Python web framework and go build a website. right? If you want to learn how to build, you know, visual novels and you want to use Python for it, then go go pick up RenPy and build a visual novel, right? Doesn't have to be great. Like it can be a visual novel just for yourself, right? But like the idea is that you need to solve a problem for yourself effectively, and that's the best. I've found it is the absolute best way to learn a language or learn any system is solve a problem for yourself or go to school, right? Um, so that's usually the what I suggest to people. It's really difficult to get people to actually do it. You'd be surprised at how many people just give up. They're fine with tutorials. Like I have some friends that will follow tutorials to the T, and they'll go through tutorials endlessly. Right? They'll plug away at it. They'll do the tutorials. They'll follow the steps. They'll think they'll learn. They're learning, right? And to be fair, they are kind of learning, but they'll do the tutorials over and over and over again and keep just doing tutorials. And they'll get nowhere because at the end of the day, tutorials aren't teaching you the most important part of programming, right? And the most important part of programming is problem solving. Because it doesn't matter how many tutorials you can do if you can't solve problems in the language, you don't know the language. That's why my suggestion is always to build something for yourself because you are the most motivated to do that in your free time. At least I am, right? And another thing that I like to suggest to people is streaming programming is actually really good. You do not have to be on camera. There's no requirement for that. You do not need the best microphone in the world, right? You do not need any fancy overlays or anything like that. You can literally go live with just your screen, right? Just this screen here. You could even do it no microphone and just chat, right? The idea is that you're keeping yourself accountable, right? By making sure that you have something that keeps you accountable, right? So the streaming aspect of it for me helps me stay on task and focused on actually doing my projects because other people are watching, right? Even if you're streaming to 0 people, you still have that as like people are watching. So you're more motivated to actually push through things or keep working at it, right? And if you set yourself a streaming schedule, uh, then you've got certain days that you've set aside, and I program on these days, and I work on the project these days, kind of thing, right? But no, it's it's a thing, right? But build things, build tools, small tools. They don't have to be big. They don't have to be big. They don't have to be complicated. They don't have to solve a problem for somebody else. They can just solve like a small problem for yourself, like your finance tracker. Your finance tracker is a great one. That's actually like a complicated app though. Like you have to hook in or scrape data from like a third party website and or like uh PDFs or something like that to get that all automated and stuff like that, right? You're dealing with math and math and decimal math, like floating point math in programming is something that a lot of people fuck up. So I don't know. It sounds like you're already on the right track though, Ashwin.
Paul. So for example, if you want to already have another character here like Louise or Paul, you can also use that as testing geometry. So both of them will work. So one of these models could be used. Now for animation, what you could simply do is what I basically have here is you can just plug it directly in FBX node, and then you can, for example, use Mixamo. So I will actually use some things from Mixamo. You can do as well, of course, if you don't necessarily have something available, you can just go to Mixamo and get an animation there as well. other animations laying around, like an emote update, or maybe already having characters correct and fully animated, you can just load in that here, and that will be good for these videos. So those are some things you can use. You can of course use other things. It's feel free to use things like metahumans or other.
Celery. Go take a look at celery. It's super important. I was in that tutorial loop. Yeah, it's hard to get out of. If you don't know celery, though, you should go learn celery. It's very important as a Python developer. Just FYI, celery, Redis. So there's some application. There's some like there's some applications and systems that you should probably learn if you want to do Python development. And if you actually want to do Python development professionally, you need Redis. You need celery. You need Postgres. Like I only say Postgres because Postgres is really the number one. But yeah. Celery. Celery is a job system. So let's say that I have a task that needs to run. The task takes 1 minute to complete. That's going to time out and kill a a 1 minute runtime is going to time out and kill a WebSocket, right? So you'll kill the connection before you finish, right? And when you kill the connection, your worker, like whatever task you're doing, could be half finished before it like could be, it could continue, it could be halfway through, it could be like what happens to the process? It dies, right? So did it complete? So anytime you have like a really long running process, right? Like something that needs to execute for a long time, you want like a celery task. And what a celery task does is it gives you essentially I've got the web server, then I've got a celery task, right? And a celery worker. And they are separate, effectively separate code bases. They're usually written together, but like they run in separate processes. So if this crashes, this doesn't. This can take 8 hours, right? The celery task could take 8 hours to execute and complete, but it doesn't bog down my web worker, my web service, right? So I've got my worker here. It can take 8 hours to execute, and I've got my website, and my website doesn't get hung for 8 hours while it waits. And that's what celery allows you to do. So super useful, but yeah, you want to have this be, yeah. So celery is super important. Redis is just most commonly because of like the way you work with these types of workers and tasks is you kind of like punt to them, and like their data is kind of ephemeral for the most part until you hit a database. So you don't really want to write it to a database and then have it read. So you use like a Redis cache because Redis is really fast, right? Need to fresh up my learning. Yeah, no worries. I need to get started on my learning session. Yeah. Wait, what? Ugh. You continue. Sorry for the hurdle. Yeah, no worries. You are always welcome to ask questions. I am not going to get mad at you. Material network. Let's actually like do her up here. Um Okay, so let's do give me a second here. Let me get this open. We're gonna build her out all nicely now. Hmm. Oh wait, you can continue to ask questions. Prefabs. This one. Where did I get the list of? Oh wait. It's these materials, right? Yeah. So okay. So this one's skin. So this one's what's her name? Kasumi skin. Which is I wish I could see these better. Okay, so this is 10, accept. Oh, here we go. Yay. Okay, so if we do, I think this is the geometry. That's the pose. And that's the animated pose? Yeah, okay. So this is the skeleton, this is the current pose. This is the animation and this is the geo. Material. So we do this, right? And then we can do skin. Oops. There we go. Sweet. Okay, that worked. Um, so this is going to be the eye highlights. At least I think that's what it was. Okay, so eye highlights. is 3. So then we come over to here and we go to 3. And we're going to do iris. Okay. And wait, no, that's 3. Wait. That one's 3. That's the highlight. Oh, this one's 2. Okay. Now if we come back over here, we can actually do this as well. We should probably do there. Okay, so let's do this one here, and we're gonna do this one is do eye highlights. There we go. Wait, what? Oh, there it is. Oh, I think it auto clipped the black. That's kind of cool. I wasn't entirely expecting that. I'm not even gonna lie. This one's gonna be the iris. There we go. Huh. There we go. Then we're gonna take the principal shader, and we're gonna say eye white. And this one is utilizing 6. Huh? Oh, wait, that's why. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Holy shit, 15. This is the eye whites. By the way, you don't need to be sorry for interrupting me. I do not mind when you interrupt. Eye whites. This one's going to be face brow. Seven. Let's see. Face eyeline. This one's going to be 9. Now we got the mouth. Face, mouth. Which is 1. This is the face altogether. Yeah, this is the face, but this is skin specifically. 4. Okay, this is hair back. 14. Hair back. Hair back. 14. Let's make sure that that's correct. Okay, yeah. Let's add some of these in. Okay, so this is white. So we're doing face brow is 5. Face brow. 6. Face eyeline. The mouth. That's actually like the inside of the mouth. What that one is. And 8 is going to be the actual skin for the face. That does not look right. We'll fix that in a second. uh, wait. What's that? Hair. Okay, so we did hair back. 4. Yeah, no, 4 is supposed to be face. There we go. Here we go. Okay, this is just hair. 18. Choose 15. Look at that. It's beautiful. Accessory tie. Which is 19. Or sorry, 16. Sorry. Look at that tie. Oh yeah. There's something interesting about this. This outfit is I think I'm like 80% sure this character was made in VTube no, not VTube Studio. Vroid. And it's being sold on the sold. It's this one's free, but like they've got an entire character set and that's being sold on the asset store. Bottoms. 13. Tops. Or sorry. Top 0 0 1. And then we have top 0 2. Do, 17 for the first one. And then for this one here, this one is 12. There we go. And then if we come back to here, we can add these in. I feel like I missed something. Oh, that's why I don't have the bottoms in yet. Okay, that makes sense. I was like, why am I I was like, what's going on here? What's going on? There we go. That's her outfit. That baker. Oh, wait. Okay, yeah, okay. Okay. Whew. I was like, did I save to the wrong spot? I did not. There we go. Look at that. Now let's load in an animation. Which animation do you want to load in? Mm. Okay, let's go to here.
Types of characters and animations. These are so we can just use a character importer node, and this mainly hints towards a FBX file that contains also bones and animation. So it's specifically saying here character, but if you also have like an object that has bones and simulation, bones and animation, you can also use this. So we can just here grab our FBX file. So with it imported, we have then our character. So I have just like this basic human character here, and as you can see, there's no animation on this. So we have like multiple outputs on this node. So we have here our rest geometry, we have then our capturing pose, and then we have actually the animation pose. A simple way of then actually viewing our full animation is to use a bone deforming node. So place this node.
That's
Just
the one
plug in
I was looking for. Bone deform. Bone deform. So what we do is we do this. We pop that there, this here, and this here, and then we do this.
here all the dots here, like so. And then you'll probably just, as you can see, have this animation. To like you can see that my speed is going pretty fast here. You can always go, and then you will pop animation. So we have here our rest geometry, we have then our capturing pose, and then we have actually the animation pose. A simple way of then actually viewing our full animation is to use a bone deforming node. So place this node and just plug in here all the dots here, like so. And then you will probably just, as you can see, have this animation. To like you can see that my speed is going pretty fast here. You can always go here, click this icon, and this will open like the playback options. And we want to make sure that we are enabling a real-time playback. So this will make sure that our frame.
What the fuck is going on? Well, that's a problem. Houdini transfer animation to skeleton. Animation. Wait. So weird. Why does it do this? on warm skeleton. Oh, match pose. Rig match pose. Okay, then map points. Map points. And then transfer motion. Body IK. I feel like part of these things are going to be, oops. This comes down like that. This comes over like so. Interesting. Is she even moving at all? Bring in the source target. Create one import node. Okay, this is the import. There. Match the pose. Okay, let's do this. Do this and this. Or is it like this? I think it's this that we want. Yeah, there we go. Select the rig match pose node. Click in the viewport and hit enter. Enter. In this state, now you have access to the rig match pose. How does this work? See, this one is target skeleton. Let's take a look at this one here. This is rig youtube.com. Happy affiliate anniversary. Oh, thank you. Much appreciated. Thank you so much for calling it out. How many years has it been?
This video is going to cover how you can remap mocap data onto an existing rig. So let's get started. I'm going to go to assets. I'm going to load my Sophia rig. So this Sophia asset, you can download her from the content library. I'm going to click on install and create. And there she is. But we don't actually need to see her in object level. We're going to create a
How are you doing today, by the way?
geometry container. And I'm going to just name that for etiquette and double click to go inside. So now we're going to bring Sophia into our scene. And we can do that by putting down a scene character import. And if you have an FBX character, you can just put down FBX character import and then load your file in. But in this case, Sophia is an object level rig, so we can bring her in using the scene character import. We're going to turn off all these extra things because we don't need them. And then because I'm lazy, I'm going to just hit tab and type bone deform.
That's good
and
to
hit
hear.
enter so that I can get my 3 wires connected. Now we're going to import our animation. So I'm going to type FBX animation import, and I'm going to load my mocap clip that I got from Mixamo. And if I put the display flag on that and just scrub through it, there's our animation. So now begins our process to map this information onto our rig. So we can do that by putting rig match pose. And I'm going to hold down the J key and just connect my nodes like so. Select that and hit the R key to get the display flag on it. And then I'm going to hit spacebar 3, hit the enter key, and I can see I'm in my rig match pose state. So I'm going to click on tweak rotate links, and this allows me to just quickly adjust the rotation orientation of my
uh, watching YouTube at tutorials at 1 time speed is challenging at times.
Select that and hit the R key to get the display flag on it, and then I'm going to hit spacebar 3, hit the enter key, and I can see I'm in my rig match pose state. So I'm going to click on tweak rotate links, and this allows me to just quickly adjust the rotation orientation of
Wait. Mm. Like I suppose. What's going on here? I don't think that's gonna work.
of my mocap data to better match Sophia, and then we'll just see how far we get with that. I'm just going to deselect this guy here because we don't need that, and I'm going to click on the rig match pose, hit tab, and then type map points, shift enter, and I'm going to get my auto wiring like so, and I'm going to move my animation a little bit forward so that I can better see what I'm mapping to what. So if I hover over, I don't actually, oh, there we go. I can see my names of the joints that I'm going to map to, so I just simply click, and then find the corresponding joint.
Okay, this is important. This is probably the one that I wanted here.
Animation a little bit forward so that I can better see what I'm mapping to what. So if I hover over, I don't actually, oh, there we go. I can see my names of the joints that I'm going to map to, so I just simply click, and then find the corresponding.
Okay, so all we need to do is go like this. Okay, so wait. Is this actually 2? Oh. Interesting. No. No. Where was I? Oh, there we go. There we go. The hand is definitely my least favorite one to map right now. That one did not map. There we go. Wait, this didn't map, did it? Ah, fuck, it didn't. Index finger. Wait. Oh, that's why. It's mapped wrong. That one's there. Wait. No, it's not. Okay. Whew. There we go. Hands are done. Booyah. This is 2 bones or 1? Oh. Left. Right. Right. Left. Neck. There we go. I think that about lines up everything. Upper chest. think that about sums it all up there.
Joint, and then just click on that to connect the two, to map them to each other. If I don't want to have that connection, I can just hold down Control, click on the joint, and click off of it to disconnect. So again, just click. Neck, let's just see that. If you get the thing wrong, just remap it again. So here I clicked on the shoulder. I'm going to hold down Shift, and as I do that, I'm going to click the corresponding one here, and I can see that automatically by holding down Shift, I get the mirrored mapping as well for the other side, which is great because that's half the clicks. So we'll do that down here. You can see that.
If I had watched a little bit further, that would have taken me last time.
I have an additional joint, and it's allowing this pop-up is allowing us to choose which one. So I'm going to leg, and I didn't actually hold down Shift this time, so I forgot. So I'll just do the other one. So now I'm back to holding down Shift, click, 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 and really don't worry if you click on the wrong thing. Just simply remap it. So like so, and then well, let's just see what we get with this initial mapping. So I'm going to hit Tab and put down full body IK, Shift Enter, and well, looks pretty much mapped, right? So
Let's see if it's mapped. Theirs worked. Mine didn't.
let's just plug that into the bony form and see what we get. Right, so obviously she's mapping. So I'm going to hit Tab, and I can see that automatically by holding down Shift, I cap data to better match Sophia, and then we'll just see how far we get with that. I'm just going to deselect this. Yeah, what? So again, just click. Now allowing this pop-up is allowing us to choose which one. So I'm going to pick remap it. So like so, and then well, let's just see what we get with this initial mapping. So I'm going to hit Tab and put down full body IK, Shift Enter, and well, looks pretty much mapped, right? So let's just plug that into the bony form and see what we get.
We got nothing. None of it worked. Wait. Wait, the legs moved, right? Oh, it did work. Wait, what? There. Did she shrink? It's really bad. The arms are not moving. Okay, so what we're gonna do is we're gonna do this. I wanna try something. Auto map. Huh. Interesting. So this is how animations work. Oh. Well, that's more than just a little bit annoying. I wonder if I import this character into if I import it into Unreal and then I do the transfer, right? To like transfer the animation to match that bone. Like do their uh animation thing. If that will fix the problem. I feel like the answer is probably yes. But let's try something first. Oops. Do, 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 do. Rate of 24 FPS. What was the frame here? Zero point 0.8. What? Oh, it's 24. So we want to go to 24. Oops. What the fuck is going on there? Frame 3? That's so bad. Let's see. Unity Asset Store. Okay, we're in. 3D characters, anime. Does she come with animations? Of course. It said I was logged in. I love it when it does stuff like that. So kind. So kind. Wait, what's this? Oh, okay. This is like an animation editing tool. Not what I'm looking for, but I get it. I think I was looking at this, but this is like. Wait, this is not as old as I thought it was. This doesn't have any docs though. Big animation. Mhm. What was this one again? This is GPU animator. What am I looking at again? Oh yeah, here. Okay. Am I in animations? I thought I was in 3D characters. Wait a second. This actually might be it.
Today's topic is MeshBaker, what it is and why you should use it. To see an example of MeshBaker being used, check out the next tutorial. MeshBaker speeds up rendering by reducing draw calls, batches, and set pass calls. The graphics processing unit, or GPU, in your computer is in charge of drawing everything you see on screen. Your CPU, the brain of the computer, sends the GPU instructions like, I need a cube drawn over here, and it should be red. The GPU is like an assembly line, with many workers called cores that process mesh vertices and paint pixels. Whenever the GPU takes these instructions and uses them to draw an object, we call it a draw call. Unity sometimes groups these draw calls into batches. Draw calls and batches interrupt the GPU assembly line. It's like a factory being reconfigured to manufacture something different. Cores sit idle waiting for other cores to finish working, and waiting while new draw call data is loaded into the GPU. The more draw calls there are, the more interruptions there are for the GPU, and the longer it takes to get its work done. This is where MeshBaker comes in. MeshBaker is a tool that reduces the number of draw calls and batches the GPU needs to render. It combines objects together and helps them share materials. A mesh defines what something looks like. We take many meshes that require a draw call each, and bake them together into one combined mesh that is drawn all at once. Rather than instructing the GPU to draw one cube 3 times, MeshBaker changes the instruction to draw 3 cubes 1 time. The following is a basic example of MeshBaker in action. Here we have around 1,300 different red and blue dice. If we run the project, we can
Okay, so this isn't quite
our
it.
GPU has had to process around 1,200 batches. This measures the amount of work our GPU had to do. After using MeshBaker to bake these 1,300 dice into one large mesh, our GPU now only had to process 12 batches, and the end result looks exactly the same. By saving the GPU work, our project can run better and on less powerful devices. Unity already has built-in tools for batching draw calls, but they only work on objects that are similar.
Oh,
MeshBaker
create
helps us by making
customizable
dissimilar
skinned
objects similar
meshes.
so they can be batched together, combining many meshes that are close together, modifying prefabs so that they can be batched easily too, and combining both skinned and non-skinned meshes. In the next MeshBaker tutorial, we will explore
Fucking finally found it. Grouper. Does this do what I want it to?
Source meshes can often have multiple materials. This is common when parts of a mesh have very different materials. For example, human skin versus clothing. Other common examples are trees which use an opaque material for the trunk and a transparent material for the leaves, or buildings which have parts made of very different materials like brick, metal, wood, or glass. Multiple materials are also common when parts of a mesh tile. A mesh with multiple materials will be created or modeled with more than one list of triangles. Each list of triangles is called a submesh. Each submesh can be assigned its own material, and each separate material requires its own draw call, so it's desirable to have as few submeshes as possible. MeshBaker, with the default settings, will collapse all the submeshes into a single list of triangles. Tiling will be baked into the atlas. This often works well, so it's worth trying this initially to see if it works. However, sometimes there's too much tiling to fit into an atlas, or the materials are too different to be combined. For example, transparent glass and opaque stone. In this case, it's necessary to use the multiple materials feature to create a combined mesh that has multiple materials. This feature works by creating more than one combined material. Each combined material can have several source materials. For example, we can bake several different kinds of trees together, and there will be 2 combined materials, one for the trunks and one for the leaves. Let's try baking some of these buildings together with multiple materials. The multiple materials tool is part of the Texture Baker component. Watch our tutorial on Texture Baker Basics to learn how to create one and add your source objects. Now we can check off the multiple combined materials box, which will bring up this dialog, which we'll use to map all of our source materials to different submeshes. For this first example, we're going to ignore the automatic.
I'll be right back. I'm gonna go grab a drink. just waiting for my hot water to finish boiling. I wanted this for the characters because like there's no reason for them to have like there is because if you're like up close and personal, it makes sense. But like, yeah.
Today we will discuss combining skinned meshes. Meshbaker can combine mesh renderer meshes and skinned meshes into combined skinned meshes. Here are some common examples. Many skinned meshes active at once, like this flock of birds or a group of characters, can all be combined together into a single skinned mesh that uses one draw call. Skinned mesh body parts and clothing can be combined dynamically at runtime to create customized characters without rendering extra draw calls for each body part. Regular mesh renderer meshes can be combined with skinned meshes, allowing you to add tools, weapons, or armor to skinned mesh characters without adding extra draw calls. Here is a window that breaks into hundreds of fragments. Normally all the fragments would be rendered separately using hundreds of draw calls. Meshbaker can combine these renderers into a single skinned mesh so that it uses a single draw call. Combining skinned meshes is very similar to combining regular meshes. The main difference is that the renderer setting should be set to skinned mesh renderer. The following tutorials describe this workflow in detail. See links in the description. Here we will demonstrate the basic workflow using a texture baker and meshbaker. First, create a texture baker and meshbaker component. Add source objects to the texture baker, either by dragging them to the objects to be combined, or using the tools for adding objects. Create an empty asset for the combined material, and bake the atlas that the combined skinned mesh will use. Once that's ready, make sure the renderer setting on the meshbaker is set to skinned mesh renderer. Finally, you can bake the combined mesh, and remember to disable the renderers on the source objects as well. Now there's a combined skinned mesh in the scene. This combined mesh reuses the bones used by the source meshes. Any scripts, animators, triggers, or colliders that move the source bones will now deform the combined mesh exactly as the source meshes were animated. The bone transforms used by the combined and remove tools for adding objects. Create an empty asset for the combined material, and bake the atlas that the combined skinned mesh will use. Once that's ready, make sure the renderer setting on the meshbaker is set to skinned mesh renderer. Finally, you can bake the combined mesh, and remember to disable the renderers on the source objects as well. Now there's a combined skinned mesh in the scene. This combined mesh reuses the bones used by the source meshes. Any scripts, animators, triggers, or
Interesting. Give me a second here. I want to go to let's go to here. We're gonna go to here, and I'm gonna just ask because like I'm not finding a ton on this one. Resources. I think vertex animations are not super. Maybe here. Oh, actually, shaders would probably be a good one. I'll be right back. Uh, okay, so the general idea of vertex animations is that you effectively have these chunks, right? And they hold the vertex information for a character. It's like the specific locations of everything and something like that. I don't know. It's interesting. Is this the person who did the one that I'm currently working with? I don't think it is. No, it's not. Okay. Happy. Hello and welcome. One shape control. Uh, That's not really what we're looking for. But this is ECS based. And I don't know if this works outside of ECS. Also, it doesn't have any documentation. Yeah. Yeah, I'm making something, but ow, fuck. Right now I'm trying to get animation vertex animations going. Um this actually seems this so far this is like this one here is the best that I've found for what we're looking for. Uh, there was one that we were looking at. Wait a second. This one also. auto texture tiling. There was one, it was... Whoa, this one's really expensive. There was one. I had it. Had it open. Not this one. It's the same one that we already looked at. There was one, and it was relatively. This is, I think, exactly what we're looking for, though. Flipnote is an encoder and decoder tool for bone tool of bone weights on each vertex and on each bone. This tool enables us to animate meshes without using skinned mesh render components. Animation without skinned mesh render. Compatible with GPU instancing. Bone positions are accessible from shaders. Support normal shadows. Tested only on some hardware on Windows. GPU must support vertex texture fetch functionality. I'll show you. Let's see if I can find an this is using Unity. But this is what it looks like, right? So let's assume that every line is one frame of the animation. So every line here would contain enough information effectively to move the vertices, to visually shift the vertices of the character as they, for a walking animation. And let's say that this chunk here, like this from the start to here, is one animation. Like this could be the walk cycle, and then this could be the idle. From there to here could be the idle or something like that, right? Anyway, so so here you can kind of see it, right? So this is the mesh, and this is what you see. So the mesh is here, and you can see that it's shifting. And then when you run it correct, like if you run it through a shader that's compatible, you can see the movement. Right? And so if I open up the game that I'm working on, right? So let's go like this. So right now I have 200 units walking. Right? My FPS is at 40, 42, 43, right? Which is not good. And the bottleneck comes down to the bones, right? So it's the animations that have caused the problem. Right? But like all of these don't have to have simulated bones, right? Because simulating bones is expensive. it's much more efficient to effectively what we can do is we can take this character mesh, send it to the GPU, have it instanced and sent to the GPU and just be like, hey, GPU, I would like to, you know, do X, Y, or Z, right? So we take this, we send this one mesh to the GPU, and we send the material information to it, right? And then the GPU we just tell it we want to do 1,000. And then the GPU takes care of drawing all 1,000 to the screen at once. And we don't have to batch them and send them over individually. Right now, these 200 are all sent individually because they have to be computed on the CPU and then sent to the GPU. The idea is that we send all the information at once to the GPU for the character, and it draws all iterations of this instances of the character at once, and you get huge performance gains. But this is what it looks like, right? And oh my god, I finally found what I was looking for. It took a while. I've been looking for this for all weekend. I was like trying to find this stuff, and then like I look it up once on fucking stream, and voila. Most of our 3D games tend to feature big numbers of moving characters. This can have a big impact on uh, uh, on a phone's. Oh, this is talking about mobile gaming. Interesting. Phone's CPU performance. To overcome this CPU limitation, I instead shift the workload to the GPU by animating each vertex with a shader. Skin mesh animation to check exactly how slow the traditional way of animating characters is. I ran a little test to see roughly how many little robot grunts I can animate before my phone dips below 30 FPS or my Samsung Galaxy is. The answer was 441. Not too bad, actually. I thought that number will be a lot lower. So why can we animate only 441 characters? Do you ask? We are getting CPU bound because of the following reason. 441 draw calls is tough on a mobile device, which is crazy because like we're hitting that upper limit right now as well, right? We're at 6,000 batches, right? So this is 6,000 draw calls, roughly, right? Like it's not a precise. This is not precise, but the idea is one batch is a draw call. Animators to update every frame. Joints to update every frame. Right, like it's insane. Introducing VAT. To overcome this CPU limitation, we can try and animate those little fellas using the GPU instead. We decided to try a technique called vertex animation textures, or VAT for short. The technique was heavily inspired by and expanded upon a blog from. Please have a look. It is an excellent read. Luis Otavio Vasconcello. I probably butchered the fuck out of that. We'll take a look. Most people relate shaders to surface material properties, but you can also use them to make geometry appear as if it's deforming. To illustrate this concept, I made a shader that samples a black and white texture gradient over time and uses the value to deform the vertices of a plane in the y-axis. But what if we want to move a more complex vertex motion in 3D space? To do that, we can use the VAT technique. First, we need to bake an animation texture. To encode the position data of each vertex for each frame, we had to write a custom C# editor tool for Unity. The main goal here is to store the world position of a vertex to an RGB value of a pixel. The challenge is that the world position needs a lot more precision than what a single pixel can hold. After all, we have only 255 values per channel. One approach to fix the issue is to use an HDR texture, but those can become quite large and not all mobile devices support them. Another approach is to establish the bounding box of the model beforehand and not store any values outside of it. This will lower the range requirements significantly. Yes, it does. What the? Weird. Here we, so here's what it looks like. Position. Huh. We'll copy and paste that later. Here we encounter another issue. The model on the right gets clipped by the bounding box limit we set because on the static model we need to calculate the bounding box not based on the mesh but based on the minimum and maximum range of all the animations. That's easy enough using the Unity Playables API. It allows us to play back animations via C# and recalculate the bounding box for each frame. We then just need to find the maximum value out of all the frames. That's pretty handy. Even with having a fairly small bounding box, we still face imprecision issues because of the limited amount of data we can store in each pixel. Fortunately, the model is fairly simple on screen, and we only notice the artifacts on very slow animations if we zoom in closely. We can actually probably get away with that because we're not actually going to be that close to these characters. The animation data is not very precise, which gives us this vertex swimming result. After all, we can finally save on the animation data as a texture. Each pixel in the x-axis corresponds to a vertex from the model, and each pixel in the y-axis is a frame from the animation. If we combine all the different animations like walk, run, and shoot into a single texture, it looks something like this. There we go. So the x axis, I think this side here is a vertex, and the y axis is a frame. Shader playback. Now that we have all the data baked into a texture, it's time to read it back in the shader. We can sample the y-axis of the texture via underscore time.y. But how do we know which vertex belongs to each pixel in the x-axis? For that, we can use C# once again to encode the vertex ID into the second UV channel of the mesh to avoid storing crazy large values of for meshes with a lot of vertices. We can remap the range to a 0, 1 value. Additionally, we need to offset each UV via half a pixel in order to avoid sampling the neighboring pixel later in the shader. I wonder if this I should probably I don't want to scroll down too far yet, but I wonder if they provide a sample project. They have a lot of sample code, but I don't know if the code is full or not. Anyways. Like this remap. I think this is a Unity shader. Oh, this is a shader graph. Ah, this is it. Sweet. Since we are storing each frame. Okay. Now we can have both axes, and we can finally sample the texture into the vertex shader program. Texture time. Since we are storing each frame data into a row of pixels, it means we can achieve some interesting results depending on the texture filtering mode of the VAT. The intended playback of each animation is 30 frames per second, but very often we would want to speed up or slow down animations. Point filtering gives us stepped animations, which is good if you are looking for a stylized look. For most cases, though, we should switch to bilinear filtering so we can get smooth blending between each frame, even if we slow down time. As you can see, we have point filtering on the left and bilinear filtering on the right. One problem we have with bilinear filtering is that we are sampling every value from the neighboring pixel. This is what gives us the smooth blending, but at the same time, it can cause problems at the first and last frame of the animation. This happens because we store all. I feel like I don't see it. All our different animations on the same texture. The way we go around that is to duplicate the last frame of the animation to add an extra pixel of padding like so. The padding is replaced with white pixels for illustration purposes. During playback in the game, we very often want to speed up or slow down an animation. Since the animation is all done in the shader now, we can do that with a material parameter. This introduces an issue, however, if we simply multiply the speed parameter by time y variable, and change it, we get skipping the animation instead of a smooth transition. To fix that, instead of relying on the built-in shader time variable, we feed our own time variable via C#. This time, instead of multiplying the elapsed time via a speed parameter, we just add times speed and pass that to the shader. The results were exactly what we wanted. It will be difficult to achieve this with pure shader code. Interesting. Very often we want to blend two different animations. For example, the robot can start with a walk cycle but slowly transition into animations as he speeds up. We get this functionality out of the box with Unity Animator components, but to do that with this technique, we need to do some extra work. Sampling two places at the same time. Interesting. Sample the current animation, sample the previous animation, blend. Yeah, that makes sense. The solution here is to sample the current and previous animation at the same time and linearly interpolate between them for a set amount of time. When it's time to switch, it does make the shader twice as expensive, but it doesn't matter too much since it's already very cheap. The current animation time and previous animation time are calculated in a C# script attached to the game object. Okay, let's watch this guy's YouTube video. That's not really what I was expecting.
That texture technique, also known as morphing animations, consists of baking animations into a texture map for use later in Vertex Shader, in the Vertex Shader. This technique enables us to keep the mesh completely static on the GPU side, changing the skeletal mesh renderer component to mesh renderer component. And here at Wildlife, we are using this technique in our game. If you are a Clash player, is this like Clash of Clans or whatever? Interesting. You probably have seen the crowds move when you score. Yep, this is the technique used. It's nice, isn't it? Let's check how the technique works. We ran a test using a low-end device. doo-doo-doo. We ran a test using a low-end device. The scene has more than 2,000 instances. Each has 800 vertices. You can see there's no frame drop even with many other systems running at the same time. But now you should be wondering how this technique works. We will tell you we ran the animation. We'll tell you we ran the animation, and for each frame we read the local space vertex position. We store this information in a vertex. This array will be in the size where each call is a vector 3 because normals are different at each frame of the animation. We must also store them in another matrix. The same as the vertices. The information of these arrays will be accessed in the vertex shader. The most common way to read vertex in the vertex shader is by using textures. Although textures are most commonly used to store color information, albedo, roughness map, specular, tint map, etc., textures can also be used to store any kind of information, e.g. normal map. To store the vertical and normal position information, we choose to use the RGB half texture. This format gives us 16 bits per channel. We then map our matrix in such a way that we write I think I get it. In the vertex shader, we sample the texture using the tuple vertex ID anim frame. What I'm trying to figure out is how do we sample it? This is really good. I'm gonna save this. In this one. Okay, let's start taking a look at this. Okay, so this here is our sample code that runs to, let's take a look at what this looks like. Oh, okay. This is getting our bounding box, right? For that, we use C#. Uh, use VAT function at the interesting. VAT baker output. Transform cache scope. VAT baker window for animation. Game property. Update skin and clips from game object. Bake. Here we go. Bake. Bake clip. This is what we've been looking for. So here we go. Bake clip. This is the animation clip here. Okay, yeah, this does all the baking. Okay, so Vertex, let's copy this and we're gonna copy this and paste this into our thing. Here. And this is in editor. Okay, so we're gonna do wait, so where Unity, where to put editor scripts. Because I think it's like top level.
If we have editor scripts within the assets folder and try to build our game, Unity will throw an error as it cannot find their namespaces or types. That's because our editor file shall not go into our game build as our game doesn't really need them. Thankfully, Unity has something called special folder names. They are simply reserved folder names with specific behaviors, and one of them is exactly what we need, the editor folder. Unity knows that any file that's
Okay, so we go here and we do an add a directory editor. Add a Unity script. VAT Baker. VAT Baker core. Oh, this is not. This is not using. Interesting. Namespace. So kid dot editor dot editor. $48. Actually, let's do this. We'll download the zip. Sense. Packages. Delete. Okay, so now we have these things. What's the issue now? What line was this on? 104. Is it that one? It's this one here. Oh, this is in the runtime. Do do do. Create a folder. This would be VAT system. Namespace, VAT Baker. Here we go. Okay, so now that we have all of this, let's build. Generate asset. This is the one that we care about? Yeah. Combine path and create folder if not exists. Subfolder. Get texture. Base should be base shader bump map. Skin bake mesh. Is not used in actual display. A static mesh will receive skinned mesh. Other component for the skinned mesh. Wait, what? Oh, okay, wait. What? Wait. Where's skin coming from? Oh, skin is passed in. Animation clip. Attach. what I really, really ideally want is like, why does Unity not have something for this? When was this? Two shader graphs. Oh, I like this. Wait. Oh, okay. It's MIT license though. Okay, so how do we add this? Right, I think we just need this. Oops. Do. Create a folder. Did I accidentally delete scripts? No, okay, good. Vat Baker. Let's see if this works. I think it does. Kind of wondering why they don't like sell this on the store. Nice. Look at that. Is that a jump? Oh no, it's a standing. Neat. Oh, there's our animations. Ugh. Okay. Okay, so if we come into here, there we go. They're training this guy here. Uh, okay. Oh, cool. Okay, let's test it. Open the tool window. Assign a prefab with a skinned mesh renderer. Okay. Tools at Baker. Let's go to my prefabs. So I'm select an animation clip from the list. Walk forward. It's our only one. Just the animation length and frame step. I feel like this is supposed to show us what we're looking for. Like actually be the animation, but it's not. It's not showing the animation at all. Label bake. Wow, look at those. Okay, so this is the animation. You'll need to manually adjust the texture using a preset or by editing their imports. Create a material and assign VAT debug shader. We have a material. Oh yeah. We don't really have much of a material here. Okay, let's go to materials. Oh yeah, I don't think I have the materials. Yeah, I haven't brought them in as I don't think I brought them in. Oh no, I did. Shaders. Uh, both graph in a real shader. Only use visual. Okay. Select an animation clip. Using presets or by editing their import settings. Generate mid maps. we go. That's pretty easy. Create a material and assign VAT debug shader, for example. So we need to create a material. I feel like this needs to be a shader graph. VAT shader. VAT base. Character. VAT debug. This one here is what we're looking for, right? Y- that baker. Shaders. Okay, interesting. Total. So if I do this and I duplicate this, can I just do this? See. There we go. Now we can come into here and we can actually make changes. Position text. Yeah, here. And then texture 2D. And this will be base color. What? Why can't I do this? What the fuck is going on? Oh, is it because there's no texture maybe? What if we give a default texture of sure this. Can I then put that into there? What the fuck? Does this No, that's a triplanar. That's not what we care about. It is nice that it comes with a triplanar, but why can't we add this here? I don't get it. What is the type here? I'm guessing this is this is probably a vector 4. This is a vector 3, right? I gotta go watch like a fuck ton of videos or something like that. All right, I think I'm gonna call it a night for now. our day for now, and I will catch you guys later. Thanks so much to everybody who showed up, and I will see you tomorrow. Hopefully, we'll make it a bit further tomorrow. I'm gonna go do some research. Anyways, ta-ta for now.